I expect that probably more than half of my probability of dying in the next 10 years is from that.
Yes.
So
Okay.
yeah. But that being said, probably 50% or more than 50%, I expect, or like a bit more, I expect things to go really well, like much better than like current life for like the vast majority of people, if not literally all people.
Hi everyone, I'm Balázs, the host of the iScientist podcast, and I'm really happy to introduce my third guest. Today is Bogdan Cirstea, a Romanian origin person who I knew as a student almost 10 years ago. The time is really flying, right? And I remember you were around all the hackathons that we organized when I was the head of the Center for Data Science. You were a fixture actually, and I remember we had a lot of interesting conversations that time. But then we went in different directions, and you went in a very interesting direction, and I will ask you about that a little bit later. But let's start with your personal journey. So I know you came from Romania, you did a master there in Bucharest, and then you suddenly joined MVA, which is the best AI master in Paris. Like, we know that anybody comes from there, we can accept it for a PhD. So how did this happen, and how did you, when you grew up, how did you decide to become a scientist?
Yeah, thanks for the invitation. Very excited to be here and to chat. Yeah, so I have a background in a bachelor's in computer engineering in Romania, or kind of like the equivalent of an M1. So that's what happened before I joined MVA. But actually, I had done one Erasmus year in France at Pierre Marie Curie, at Université Pierre Marie Curie. So that like influenced, that definitely influenced me being in France for the MVA. On becoming a scientist, I guess, to be honest, I'm not sure I had, yeah, I'm not sure in my mind it was becoming a scientist necessarily. It was more like being excited and like intellectually interested in topics like AI, and I guess maybe somewhat stereotypically, or maybe like kind of like a contrast, given that I'm now working on AI safety. I like some of my interest was started from reading Ray Kurzweil, for example. So like from like transhumanist topics in some sense. And yeah, AI. So I did a bachelor's in engineering in computer science. I had become excited about programming in high school, though relatively late in high school. Also, like software engineering jobs in Romania seemed really well paid, so that also played a part. So initially I thought, I don't know, maybe I would just become a software engineer in Romania. I didn't necessarily think I would do research in AI. But like, so like it was a mix of all of those factors. And then in university, I became more excited about like AI in particular. And yeah, that's what led to the end there.
I see. And so MVI is a master in Paris. So after that, you did a PhD, and you did your PhD at Telecom Paris Tech. You finished in 2016, right?
A bit later, so end of 2018.
Okay.
Yeah.
And your PhD was on handwriting recognition, and you used as a specific architecture that became very well known since. But that time you were one of the pioneers who actually touched it, right? So what
Yeah,
was that?
so yeah, so actually my to be totally honest, my interest in that PhD was like mostly around deep learning. Handwriting recognition was just, yeah, one application area that turned out to be like the PhD program I got into. But I was mostly excited about deep learning, and I actually had a year in industry in between my master's and starting the PhD. And already at that time I had seen, it was around 2013, so You know, the DeepMind, DQ, and Atari paper came out then, and also Vervaeke came out, and those made a bit of an impression on me. So yeah, I think those were two big factors. Also during the masters too, I had been interested in deep learning, though I wasn't super familiar with it at the time. But I was excited about deep belief networks, for example.
But you worked specifically on transformers, right?
No, I actually worked on LSTMs.
I see. Okay. Okay,
I
I
worked mostly
misread.
with LSTMs, and I also had, towards the end of my PhD, I tried to combine classical recurrent neural networks with kind of like a quantum computing architecture. So I didn't end up actually working with transformers during my PhD, but I did work with recurrent neural networks.
Okay, so then you did an interesting move. So you went to Oxford to do a postdoc, but not in a computer science department, no?
Actually, yeah. So I did a postdoc with Fabio Cuzzolin, but the project in machine learning, but the project was at the intersection of machine learning and neuroscience. So with collaborators, so at Oxford Brookes University, I should say, and with collaborators from Cambridge University, from the neuroscience department there. Looking at machine theory of mind. So theory of mind is this set of capabilities, I guess, of people to infer the mental states of others. And so I was very interested. So yeah, maybe this will already go a bit into the safety side, but like during my PhD, I became so like I had bought into the AI safety arguments since around 2013 or 2014. So definitely after Superintelligence came out in 2014 and I read it, I was kind of convinced that at some point that this would be a problem at some point, and that maybe I might want to work on this at some point. But I thought at the time that point might be quite far off. So maybe, I don't know, 2045, 2050, and maybe I would get the chance to become a machine learning professor or something like that. And then I would be well placed to do research on that. Also, at the time when I was looking at the existing research around 2013 or 2014, it just seemed very mathematical and very abstract. I wasn't sure how I could contribute anyway, even if I wanted to, because I felt like I was more on the engineering side, more on computer science, machine learning. So yeah, at the time it felt like, okay, seems interesting, seems like a big problem at some point, but maybe like I wasn't sure what to do about it. And then as my PhD went on, and because I was actually looking at the state of the field, things kept happening faster than I thought they would. So AlphaGo happened, all the like Starcraft playing, Dota playing agents happened. And then of course, already around 2018, 2019, BART happened, and some other, GPT-2 happened. So already some decent language models. And this one was probably the one I expected least. So language models were I expected language processing capabilities to happen much later.
Why?
Because it feels like one of the most human capabilities. Like I don't think it's all of intelligence or anything, but it's like a very distinct human capability. And I would have expected it to happen. I mean, maybe I would still expect it now, actually, to happen relatively close to when we might get something like human level AI or like very capable AI in general. And so all of those seemed like warning signs that things might happen sooner. And like, yeah, I might want to adjust my plans. Like if, yeah.
So what was your guess that time? What would happen before language models, I don't know, get to this level of GPT-4?
Oh, I didn't necessarily have like a very strict ordering or something like that. I just thought that things would move slower than they did. And so because they moved faster, I felt like maybe I should try to get try to get as close to AI safety as soon as I can. And like instead of trying to wait to become a professor and then decide on and like have freedom to work on whatever, maybe I should just like try to make moves to getting closer to it. And so that's how like working in that postdoc happened.
Okay.
Yeah, I should say. So yeah, on the theory of mind, I was especially interested, I still am, in like inferring preferences, like inferring other humans' preferences, and also like being motivated to fulfill others' preferences for like ultimate reasons. And so that was the part which I was most interested in, which seemed and still seems very relevant to safety. Although in the meantime, I'm also interested in like inferring beliefs, the inferring belief side of theory of mind. But now I think more from an evaluations point of view, like if a model can infer your beliefs really well, it might also be very capable of manipulating you, of lying to you. And so in the meantime, I've kind of like my interest in theory of mind has expanded even more.
Okay. So we'll get there because I'm really curious about the relationship between theory of mind and safety. But let's just finish the personal journey, because you did a very interesting move after your postdoc, which is it's quite rare. You already explained it a little bit what your thinking was, but I don't actually know what you do now. It seems like your LinkedIn page, you are an independent researcher on AI safety. How does it work?
Yeah, so it's it's kind of a funny story, I guess, and like maybe even more idiosyncratic than the story I've already told. So after starting my postdoc, so like before starting my postdoc, I think I had applied. There's this 80,000 hours website, which is like this website which gives free counseling advice for people who want to potentially do the most good they can with their career. And so I was so like one of their areas of like one area people might apply their careers to potentially do the most good is AI safety. And so I had found out, I don't actually remember exactly how I came across that website, but there is a bit of intersection between AI safety and 8,000 hours, and more generally a social movement called effective altruism. And so I came across that website. I applied for counseling. I think I got rejected, but somebody from Effective Altruism Oxford got in contact with me. I don't know if they were redirected from 8,000 hours or how it happened. I don't remember exactly. But basically, they suggested that I might want to do this effective altruism in-depth fellowship, which was kind of like getting into like more depth into all these topics, including AI safety and others. And so I did that. It happened that the facilitator of that program got involved in organizing this AGI Safety Fundamentals, which is kind of like a remote course in some sense, or like remote reading groups, I guess. And so I did that. And then I became kind of like I don't know how I should put it. We're called facilitators, I guess, which is kind of like a reading group. Yeah, I don't know what the term is. Like you basically try to steer the conversation, or like help with some explanation, help with some explanations and so on. And so like that was kind of like an idiosyncratic way that I got into field building, I guess, because this program is about like getting people familiar with the basics of AI safety. And I think that together with the fact that I had quite a bit of space, and I'm like very, very grateful for that during my postdoc, think about AI safety in general, that led me to being in a pretty good position, I guess, to apply for independent funding, actually, so to do independent research on AI safety. And I also keep doing AI safety community building, which looks quite similar to that reading group, except that most recently I've been doing it in AI safety boot camps in person. So yeah, so I'm funded. I'm funded by Center on Long-Term Risk, which is an organization focused on risks. They're mostly focused on suffering risks, actually, including and they're mostly from AI. To do mostly independent AI safety research, and I also keep doing some community AI safety field building activities. And also my funding, so this is also like the topics I'm interested in are also very much related to what I worked on during the postdoc. So I am mostly focused on the intersection of deep learning and neuroscience, and also alignment.
So what I was asking you before the technical glitch was this unusual move to be an independent researcher and who you're working with, and maybe the next question is like, how's your day? How do you motivate yourself? Because usually when we are in a department, we have students, we are in a structure. We go in the office. I work with 20 people. It's relatively easy, but you work alone. So how do you do that? It takes a lot of stamina, no?
Yeah, so it's so actually do a few different things. So I'm involved in I lead a couple of projects, or like I'm a mentor for a couple of projects, and there so like I do engage with other people in that way. Also, I sometimes work for this from this place called Trajan House, which is a building in Oxford where more AI safety people work from, and also more people from the effective altruism community more broadly. But I think I'm so like it varies, but I think I'm pretty self-motivated in general. So I don't think I struggle that much to be motivated to work on this, both because I think the problem is really important. Unfortunately, I think it might be much more urgent than I thought in the past it might be. Um, yeah, and also I just think it's really interesting intellectually. So there's also that side of it.
Okay, so you basically work from home, right?
Most of the time, yeah.
Okay. For me, home office, it's nice for certain things, but I do want to see people. So that's why I'm asking you this question, like, who do you meet? Who do you talk to about your ideas, etc.?
Yeah, so I do talk about my ideas with mostly with other people doing AI safety research. A lot of the time with people doing similarly independent AI safety research. Also with the people from the project I lead. But yeah, that's so yeah, mostly other AI safety people.
And what's your KPI? What's your work output? What do they expect you to do?
Yeah, so I think this is quite flexible. I think most AI safety people, the way they publish work is on these websites called the Alignment Forum, also LessWrong, which is very much related, but also like archive preprints. And so I actually have a lot of drafts. I expect to start publishing a lot more of them. I actually haven't published that much. On mostly on like LessWrong and the Alignment Forum, I don't have. Yeah, we for the two projects I'm leading, I think we will have preprints normally if things go well. But yeah, I'm most of my time is spent on like trying to build a very conceptual research agenda, I guess.
I see, I see.
So for this reason, yeah, I'm not necessarily thinking about preprints. I'm mostly thinking about, yeah, what does the problem look like? Although there yeah, I'm relatively comfortable with where I am, and especially what to do about it.
Okay. It's clearer now. So let's go to the topic of the main topic of this episode, which is actually there are two. I want to talk to you about language models and safety. So let's start with language model and where are we? I play with GPT-4. I had GPT-3, 3.5, ChatGPT. I have access to GPT-4. I see the improvement. And there was a certain moment this year when people were like, every week there was something coming out. It seems that it calmed a little bit, right? So where are we now on LLMs? What's the latest big thing, the latest news? Where are we going?
Uh, to be honest, I'm not so sure if so like I think it's true. Like I do follow machine learning Twitter quite a bit, and like yeah, the pace seems a bit calmer. Though I wonder if it's not just because there aren't that many ML conference deadlines around. So around the next ML conference deadline. I'm not sure. Like, yeah, that's gonna be a good test of like to what degree things have come down or not. I worried they didn't actually. It's just like a very small hiatus in between different conference deadlines, and also being summer. Um, yeah, where we are, to be honest, I'm not sure.
So what is the, let's say, what is the most surprising thing that LLMs do today to you? Like you said in the beginning that you were surprised how fast it reached human level. What exactly?
Yeah, so I would not necessarily claim that they are. So I think it's not that easy to evaluate on which tasks or like competencies they are human level. I have just been surprised that models can just interact with humans. Like I was especially surprised that already this was starting to happen around 2018, and now some people have. I don't know if I necessarily agree with those claims, but very high-profile people like Yoshua Bengio or Geoffrey Hinton have argued that in some sense the Turing test maybe has already been passed by these kinds of systems. Which again is not like if you asked me 10 years ago when we first started chatting, I would not have expected it to happen this soon. In terms of most surprising capabilities, I guess it's in context learning, I would say, is a relatively surprising one. And so it's like a set of capabilities like these models being able to learn new tasks or like to combine previously learned tasks. In terms of like a very specific task and also related to AI safety, I've been surprised by Minerva. So like by models being able to do math very well for a bunch of reasons. One is that there used to be this argument around 2020. I think there were a couple of papers claiming that if you looked at these scaling laws of like how models tend to improve with like scale on math, it seemed like there wasn't that much improvement at the time. So people were projecting that maybe if you just scale up language models, they won't get better at math. So it seemed like maybe there would be some capabilities on which they are like inherently limited, and so language models will not lead to human level AI or something. And for
It's
me,
already surprising, isn't it, that they can do math
yeah.
trained on text mainly, or are they also trained on math?
So they are trained on archive papers, but but yeah, still. And so related to the AI safety argument, I think a lot of people in AI safety, or at least some people who had relatively influential views, didn't expected some kind of planning to be required for this kind of skills, and language models to be bad at planning, which I think is fair. Like planning is one of their weaknesses, probably.
What does it mean, planning? Explain it to those who perhaps not familiar with it.
Yeah, so I guess something like you have a state you want to reach, and then you try to optimize, you're trying to find something like the best trajectory to reach that specific state.
So I asked something to GPT-4, like a goal, like tell me how to get to New York, something like this.
Yeah.
And then GPT-4 breaks it down to steps. That's what it means. Because I use planning in a like reinforcement learning sense, which is different a little bit.
Yeah. I think the example you gave sounds reasonable. To be honest, I'm not sure how in which way you're thinking about planning in a reinforcement learning
Planning in reinforcement learning is that you have a model of the world, you simulate from the model. So it's basically the analogy for humans. It's thinking. Because what one way of thinking about thinking is that you have a model in your head, and this model simulates the world. In this model in your head, you can do certain actions which you don't really do, And at the end, if you die in your head, you don't die really. That's why we do this planning. And then you run these sort of simulations in your head. I'm talking about the reinforcement learning algorithm. So it's called rollout, where you simulate between taking an action and then looking at what state you get into according to your model. You run these simulations, and then you reach a state, and then you choose the rollout which reached the state you want to get in, and then you execute its first action. That's basically planning in a nutshell in reinforcement learning, but I think this is not used in the same way for language models.
Yeah, so I guess what I was trying to get at, so yeah, that sounds, your description sounds very reasonable, like sounds like Monte Carlo research or something like that.
Yes.
Yeah, I guess what I was trying to get at is that I would expect, so like, I would expect intuitively that a lot of math proofs like benefit from that kind of process, and the fact that language models can achieve the same results, even if it's not clear they do the same thing internally, was surprising to me, and I think probably to a few other people at least.
But in my mind, language models don't really do this. They generate the plan as text. They don't simulate various trajectories and then take the one that reached it, because they can't even check, because normally you do reinforcement learning in like robotics or self-driving car, where you do the planning and then you do execute the first step and then you check where you are really because that's a big part of the planning, because you have a good world model, but you cannot trust it completely. So you're not executing like 100 steps of your plan. You execute one step, you stop, you look where you are, and you restart the full process. That's how, say, self-driving cars control the wheel.
Yeah, so I agree that explicit, like models are not trained, like language models are not trained to do this explicitly, and they also are not like at inference, they don't do this explicitly. Although I think if you start looking at things like chain of thought and then self-consistency, I think the boundary becomes a bit less clear. And also, yeah, I think it's just interesting that behaviorally they seem able to do theorem proving, even without this like explicit mechanism.
I see. So it's like, yeah, it's what we call reactive policy in reinforcement learning, which doesn't do the planning. It just trusts its policy, what to do next, and then it works, something like that.
Yeah.
Okay, so this is the most surprising thing for you, that language models can provide plans.
I mean, maybe I should add one more, which is even more relevant from a safety point of view. If you know about the example of GPT-4 being prompted, well, I might tell the story badly, but basically GPT-4 had to got a human to provide it with the answer to a CAPTCHA test. And the human, while GPT-4 was interacting with the human asked, why do you need me to do this? Are you an AI? Are you trying, well, I'm paraphrasing, but like, are you trying to take over the world or something? And GPT-4 had chain of thought. So like the testers, so the people testing GPT-4 could see its chain of thought. And in its chain of thought, it
So what is,
said,
sorry to interrupt, what is a chain of thought and what did they exactly see?
yeah, so chain of thought is this relatively simple idea, I guess, where you have the model produce the next, you have the model output something, and its output, so like the next word, becomes its next input. And so,
but that's how it works anyway, no?
yes,
Generation.
but okay, so I should say that like specifically with chain of thought, you can have some like when you provide the final answer, for example, when GPT-4 interacted with the human, it didn't necessarily show the human the chain of thought of reasoning which led it to the final answer. So like the human it interacted with only saw its final answer. It didn't see like the the reasoning steps, the intermediate steps, which would be the chain of thought. And so
where does it appear? Because for me, GPT is basically a big neural net that takes as input history of 2000 something tokens and outputs a probability distribution for next word from which we pick one word randomly with the probability. So what else? So where does it appear in this generative process, something that's hidden?
Oh, so it's the same. So like the process is the same. It's just I think it's basically again this idea of in context learning. That is, you can prompt the model with a few examples of like these are some examples, like these are the intermediate steps, and then this is the final answer. And if you prompt it in that way, it can learn to like be able to do intermediate chain of thoughts, and then provide the final answer based on that chain of thoughts. And so, yeah.
I see. So it's basically, it produces a piece of text that it inputs it back and produces the next one and inputs it back, but it doesn't show this.
Yes, and it's formatted so that the task is only it's only scored on the task based on the final answer, not on the rest.
I see. So it's basically this other kind of thinking which we do in math, right? Like we go step by step and we sort of like mentally keep in mind the point where we reached.
Yeah, exactly.
Then we go next step. Right?
Yeah, so like the most famous prompt for this chain of thought, it's literally, let's think about this step by step. So if you prompt some language models, like some capable language models, if you prompt it with this, they can do much better on some tasks which require this kind of like multi-step kind of like reasoning.
Yeah, I remember that. Yes. Okay, I got it. So this is a surprising thing for you. So
what happened actually was that the model reasoned in chain of thought that it should not tell the human that it is an AI. Instead, it told the human it's visually impaired. And so for me, it was surprising I don't know if surprising, maybe more worrying than surprising. So it's like an instance of instrumental deception, basically. So the model lied in order to accomplish the task it was set to accomplish.
So now
that is, get a human to reply to do a captcha for it.
Now we get into the juicy stuff. Because for lying, it has to have a self. For lying, you have to know what the truth is and deliberately say the opposite. And I'm not sure if we can say this about GPT, but I understand that the interpretation, the behavior looks like lying. Can we say this?
Yeah, so maybe lying was a bit too strong of a claim, so I'm not sure. Yeah, I guess lying requires, I don't know if necessarily requires the self, but it does require the model to like know the truth and deliberately say something different. So yeah, I guess I would suspect the model was probably prompted with like you're a language model. So if you think that it's decent at processing its prompt, maybe it already knew the truth that it is not a visually impaired person, but probably like stronger evidence about what's going on inside it would be needed to make this claim like very confidently.
But the other question on this would be that, I mean, Yudkowsky talks about this a lot, that it's really hard to know. It learned, like it was fed like 4 terabytes of text, which is an immense quantity of text. And probably among that text, there is a lot of text which does this, right?
Yes.
So it learns from the text that this is possible to, when somebody asks you why do you want to solve the captcha because somebody writes how to hack, you just say that you are visually impaired. So it's somebody else who lied on the web, and that GPT just learned that.
Yeah, but that does not match with the chain of thought, right? where it was like, I am an AI and I should not say that I am an AI. Because that would have made sense. Like, sure, it could have done that just
I
because
think
it's
there are
of
a lot
that
of
kind of
science fictions where AI does this.
right. Yeah, that is also plausible, yeah.
Like HAL, to start with,
Yeah, although I
That's
guess
exactly what it did, it misled the human to reach a state which it wanted, and it was against what the human wanted. But
yeah,
that was like a science fiction, and it was a slightly different context in the sense that HAL, it's 2000 Space Odyssey. That machine was somehow embodied. It was the spaceship, and it had a task to reach, right? And he felt that the human was doing things to avoid to reach that task. So it's somehow it becomes this singularity story, which we'll get to. But it was definitely a science fiction when AI already had a will to do something, right? And I am just, when I talk to GPT-4, I don't feel this way yet, but maybe I'm mistaken.
yeah. So I think for this specific story I was telling, it's like my interpretation would be that the model was trying to do this very specific task. It was like prompted or even trained to do. And so for doing this very specific task in that specific context, it was useful for it to basically mislead the human it was interacting with. On whether GPT-4 has this kind of like will, actually, I am very much into like this framework for trying to understand language models, which is called simulators. And there are also like this was LessWrong or like Alignment Forum post. So it came from the AI safety community, but there are also a bunch of works from the broader machine learning community, which try to frame language models as doing something like Bayesian inference, as being something like simulators with multiple simulacra, and like depending on the context, a different simulacrum is instantiated.
You have to explain these things. So what do you mean by Bayesian inference and simulator and simulacra? Because our audience, I want it to be wider than just the internal machine learning experts.
Yeah. So the idea is something like if you think about the text that GPT-4 is trained on, that text is so like the entire web, to like roughly speaking. That
Everything
text is
ever written, I usually say.
Yeah, so that text is like very incoherent. So like if you look at two different web pages, they can come from like totally different perspectives. They can be written at totally different times. They can have word models which are completely incoherent and so on. And so the idea is that when you train a language model to predict the next word in all this like vast collection of text, uh, like a simplification of the story is something like it will learn text generating processes. It will learn like a mixture of text generating processes, which roughly approximates that whole mixture of like web pages. And so you should probably not expect it to learn a single coherent thing. You should probably expect it to learn like this mess, like mixture of a mess of different text producing processes. And so like,
But I would agree if it was not trained autoregressively. So basically what autoregressivity means is basically you train it to output the next word, and then you input the next word into the history. So for the word after that, the word that it generated becomes part of the text. So this is designed to generate coherent text.
but like the teaching is the like learning is with teacher forcing, right? So it only sees true inputs. It never sees its own inputs during the original pre-training.
Yeah.
So yeah. Yeah. So I guess where I was going with this is something like, so like these text producing processes are like the simulacra in that terminology. And this simulacra can be agentic, like you can, yeah, well, this is going to be like the terminology here might become. So like you can have texts which are about, I don't know, optimizing for something maybe. Like if you think about the text of a math proof, the math proof tries to go towards the answer. So it tries to go to some specific state. But the simulator, which is like the whole language model, is not agentic itself. The simulator in that framework is just kind of like doing Bayesian inference over like which process from the mixture should I now sample from. And so the
I see,
here,
I see. So it's like, okay, I'm here in the history of the text that was generated, and then I pick a submodel or a text from which now the next word will come from.
Yeah, exactly.
Right?
And so like basically I use the context, the text which was in my context, to basically try to infer from which part of that mixture I should next sample from. Yep.
Okay, and so I understand now this. What was that you were saying with this simulacra and agentic?
Yeah, so I would not, I guess for this reason, I wouldn't expect GPT-4 to be, at least after pre-training only, like before the training with human feedback, I would not expect it to be coherent, which is what you were saying, that it doesn't feel that GPT-4 doesn't necessarily feel that coherent, if I got that right.
No, it does.
Mm.
Actually, I would have, I mean, that was my impression too, like 5 years ago, that these things will never work. But then it's first, the sentences became coherent, like syntactic, and then the paragraphs were still like weird, like going from nowhere to nowhere. And then the paragraphs became coherent, but still there was no essay. And today with GPT-4, I mean, that's I think this is what surprised people, that it can generate a full essay, which is novel in a certain sense, and it's coherent. It's not necessarily true, which is the problem. But we do this too as humans, so it's not necessarily non-human. Yeah.
But I guess that's not what I meant. I meant so yeah, it can generate like long text with like relatively long pieces of text with internal coherency. But what I meant is more like it can inherit, it can like play different personas which are not coherent among themselves.
I see. So, and that's an argument for against the Turing test?
No, I guess I see it as an argument. So like, I come at this mostly from the perspective of like AI safety arguments, which in the past were a lot about what if you have this agent which has a single very specific goal, and if that goal is not like very close to human values, like it's like things could go very badly. And the point of I guess the main point of that simulator's post was something like that's not a good framework to think of about language models. So it's not like a single agent or not. It's like this simulator of different processes, some of which can be agentic actually.
Aha. So it's schizophrenic sentences.
I guess that's one way to put it. Although I have to caveat that like you might expect the reinforcement learning with human feedback process to potentially move it more towards something more coherent and more.
Yeah, actually, this is very interesting. This is very interesting because that was my impression, that without the GPT-3 had the version, I guess, which wasn't reined in yet. And I loved the confabulations, it was really interesting. That was something I was looking for, because inspiring me or generating texts that are completely out of nowhere, and then the reinforcement learning came in. It really feels like an anti-schizophrenia drug. Like it dumped down the creativity, and it was even I would say like it's, I don't know, this cognitive behavioral therapy where the goal is just to basically change your psychology through changing your behavior. And that's what I felt like. It really learned, how to behave like a little bit like a dog.
Yeah, actually, those are some very interesting remarks. So I know some people in AI safety who are actually trying to use the base models because they are trying to have GPT help them produce alignment research, and so they want a more creative model. They don't want a reined-in model for that reason. Also, your point about like kind of like cognitive behavioral therapy. Quite a few people in AI safety complain about RLHF, RL from human feedback, because it only acts like at a behavioral level. Like you don't know how the internals are changing. You're just trying to make it produce some certain behavior, but you don't really have good control over the internals.
So that brings up another experiment I did. So John Vervaeke had a remark. It was still before GPT-4. It's a very interesting dialogue Turing test, and I think it could be used more like rigorously than I did. But the basic idea is that you just take two language models and you make them dialogue. Like one, two entities of the same algorithm, but you enter what the one says as the history for the other. And for GPT-4, I could actually even explicitly ask them to do dialogue. So ask them to talk about a subject in a dialogue format. So GPT-3 was terrible at this. It went to nothingness in like 5 iterations, just repeating the same word. And GPT-4 was much more interesting, but it still didn't pass the Turing test. So this is interesting because you read the dialogue and you definitely see it's not two people. Because what happened was for certain topics, it did understand the concept of presenting the subject in dialogue format, but at a certain point it went out of it didn't spark interest in a conversation that was like in our case, like it's like meandering in all kind of topics. It went down into sort of like a fixed point. The fixed point of GPT-3 was like just the same sentence over and over. It was really, really stupid. GPT-4, it was different. It started to thank the other. I think that's definitely reinforcement learning with human feedback. Like it was really, really polite with the other GPT-4. And it kept summarizing the dialogue with different words. So it wasn't a trivial fixed point. It wasn't the same sentence over and over, but the same summary with different words, which I use, there are these tools now where you can ask to rephrase what you wrote, and that's what I felt it was doing. But it didn't have this, you really see that there's nobody behind because it doesn't really have any interest in anything or any memory of like personal stories that would trigger us or you and like you and me to go into different directions. It was really boring at the end, one would say.
Yeah, that sounds very interesting. Actually, if you publish this, or if you have already published this, this might be. It reminded me of these stories of how reinforcement learning might cause this mode collapse phenomenon, which sounds sounds like what you described for GPT-3. Like
Yeah, I have a blog
at
on
some.
this. I will
Oh,
send it to
cool,
you.
awesome.
Yeah.
Yeah,
So
the
I
GPT.
think this dialogue Turing test is still not passed. So when you mentioned that Bengio and Hinton think that we are over the Turing test, maybe in certain conversations it does, but it's definitely possible, I think, to not to trick, but to push it in a direction where it becomes obvious that there's nobody in there, you know.
Oh yeah. I think that the robustness of these systems is still very far from like human robustness. So yeah, but yeah, I'm very interested actually to read the
Okay.
post, because it sounds like a very interesting, like a less boring kind of mode collapse. I'm really curious to see what that looks
Exactly.
like.
No, that was exactly my thing. Like, I think what happens is that with reinforcement learning with human feedback, these modes are still there, but they are more complex.
Mm-hmm.
And when I asked about photography, for example, they were discussing photography, what was going on, that the two agents started to talk about different types of photography, very detailed instructions of how to do this, how to do that, how to do that. And then it was just going over and over. There were so many different types of photography that I couldn't wait to the end. You know, I don't know what would have happened at the very end, or maybe just circles back to portrait photo again. So that was also like, okay, it's not like two humans talk, you know.
Yeah, interesting.
Okay. So perhaps explain me what alignment is.
Yeah, so I think probably different people would propose different definitions depending on like how you want to frame the problem. I guess the most general framing would be something like making especially very powerful AI just go well as a whole. But that's a bit vague, I find. I'm particularly interested in this framing, which comes from Paul Cristiano, of intent alignment, which is getting the AI to try to do what you want it to do. Yeah, so that's what I'm mostly focused on, which
So
is like a
that's
narrow.
related to the theory of mind, right?
Yeah, because it has to be able to infer basically what you want it to do, though you can also help it with like communication and so on. But yeah, but like actually the part where most alignment people are focused is not what you want it to do, because I guess many of them expect that part to kind of, I guess the argument goes something like a very powerful AI will probably be able to do that anyway, or otherwise it would not be very dangerous. But it's more the motivation part, the trying to do what you want to do, which I guess a lot of the focus in alignment has been like really, yeah. I also have to say that like there's also the like AI safety is broader than that. So like you might try to make the system safer even if maybe you don't know how to solve alignment. But yeah.
Okay. So let's talk about AI safety, because one of the big issue in the debates, like there was the monk debate, I want to bring it up because there is a certain metaphor there that I like very much, where there is a sort of contradiction between immediate issues like people losing their jobs or people getting triggered by something that they read that the AI model generates, and longer term issues like singularity, which seem out of science fiction, right? So it's not necessarily people argue about whether we should do safety or not to do safety, but what is the time scale? And time scale is a killer, because basically this is why, in my opinion, even reinforcement learning, so even the learning paradigm where you have an objective and you want to reach it, is far from the paradigm that will cover intelligence, because basically time scale is what makes it unsolvable. Like you never know. It's not that you never know, but as a living being, you constantly have to balance between the things that you do in terms of time scale. Like there's an immediate danger, I have to do something, or maybe I'm thinking about next day, I lost my keys, I have to make a copy. Or maybe you're thinking about next year, or maybe you're thinking about your life goals, or maybe you're thinking about like the goal of humanity, and those things are not comparable, and you have constantly have to calibrate this timeline in which you're trying to optimize something. So what do you think about this?
I think that, so like, I'm very happy that there are quite a few people working on near-term safety issues. I personally think mostly about, well, I guess I would have called them longer-term issues, except that now I'm not so sure if they're going to be longer-term. But I do mostly think about, I guess, singularity-related scenario in some sense, or like to be more precise, scenarios involving AIs which could take over the world or make humanity extinct, or like, like very, very capable systems, and like what to do about existential safety, basically. So this falls under this idea of existential AI safety.
So which one worries you more? What is your research concentrated on more?
Yeah, so I'm mostly, so my views, like these are my particular views, like within existential AI safety, views can differ a lot, but like, I think that trying to align superintelligence directly hasn't fared well. Like approaches which try to do that haven't done very well. And so I'm mostly excited about kind of like a two-step approach, which is actually what seems to be OpenAI's main plan, which is try to align well enough models which can automate alignment research, which are maybe roughly human level, let's say, so like which are not strongly superhuman, and then use those systems in collaboration with humans to solve the more ambitious superintelligence alignment kind of problem.
I see.
And
So it's like, because I saw your tweet about this new OpenAI initiative. So they have basically three directions. First is human feedback, which is what's being done now. The second one is that I found that actually more interesting, because the third one is what you're talking about, is that basically make alignment automated with an agent. The second one was so interesting. They had this different type of collaborations, like debating or reward modeling. Like you want to model, it's exactly what you were talking about, like try to model what the other wants, right?
Yep.
Or debating, or like that's like, okay, how we align ourselves. Let's say, I don't really believe that like classical debating really works for that, but I understand the concept. Like let's do it like humans do it. Like we run a debate. So you're saying that you like the third one, the training the automated AI alignment agent?
Yeah, so I guess I'm coming from the perspective of, as far as I can tell, approaches which have tried to solve directly for aligning superintelligence haven't done really well. So I'm relatively pessimistic that alignment researchers can do that, especially if timelines are relatively short. So especially if we get powerful AI relatively soon, and given that the number of people working on these problems is relatively small. And so, yeah, unless many more people start working on this, or unless some kind of like very unexpected breakthrough happens, I'm relatively pessimistic about plans which try to solve directly for aligning superintelligence. The reason
So what can you elaborate this? So what are you pessimistic about?
I'm relatively pessimistic about trying to have human researchers directly come up with proposals which directly align superintelligence, instead of like trying to delegate parts of this research to like automated alignment research, basically.
And why? Why are you pessimistic about this?
So the reasons I'm pessimistic are that historically, the people who have tried to work on this, so Machine Intelligence Research Institute, Eliezer Yudkowsky, and related people, as far as I can tell. Well, that's a very small number of people, but like basically that line of research, as far as I can tell, hasn't done that well. So like I don't want nobody to work on it, but I want more people to work on that too, even though I'm pessimistic about it. But if I feel like if that's our main plan, we are probably gonna fail because the problem seems very hard. There aren't that many people working on it. I don't expect there to be a lot more people working on it in the near term, unless something that drastic changes, like a lot of academia suddenly starts thinking about this problem or something. And so given our like past track record, not that there's anything wrong with like what the people doing that line of research tried, but just like it seems hard. And as far as I can tell, there isn't that much progress on trying to attack the problem directly. And comparatively, I'm more optimistic about the OpenAI, especially like the super alignment post, if you saw that one. Because in principle, if you get human level alignment, if you get GPT-6 or whatever to do human level alignment research, even if you only got it to work for you for like 1 year in calendar time, that could produce the equivalent of like a lot of, I don't know, millions of years of alignment research. Just because you can run that, you can parallelize that, you can run a bunch of copies much faster. And also you can like very easily turn money into alignment research in principle if you get there. While today we are bottlenecked on talent, on money, on like everything.
So let me stop you. So basically the proposal is that we'll do these agents who will do the alignment. But aren't we just, biting our own tail there? Like who will align the aligner,
Yeah, so I don't, first of all, I like on the agent side, like, you can have a spectrum of like how much, to what degree do you delegate, like, and like how many humans do you keep in the loop, and to what degree do you keep humans in the loop or not. And I think there's like many different, yeah, that's to explore. That's like a hyperparameter to explore. Unlike, yeah, yeah, actually, people who are pessimistic about this kind of plan seem to tend to think something very similar to what you're mentioning. Like maybe this problem, like aligning roughly human level alignment researchers, like doing automated alignment research at the human level might be as hard as the whole problem, like aligning superintelligence. And in that case, yeah, it would not be productive to work on this. I am relatively more optimistic. I don't know, based on like some intuitions. Language models seem relatively easy to align if you're like actually trying to get them to help you. Like if you're not deliberately trying to mislead them, to like prompt them adversarially or so on. And so I'm relatively optimistic that on this path, if like the current trajectory will be like what the most capable AIs look like, it might be easy to, it might still be easy to automate, to like align language models, even as they get more capable. So I already mentioned Minerva, which can do math. The like alignment research looks quite a bit like that, though not only like that. So I'm relatively optimistic that you can get alignment research capabilities as these models get better at math research, machine learning research, and so on. And I'm also optimistic with respect to like, you mentioned the training signal. Yeah, so another indication for optimism is something like verifying alignment research or like doing peer review on alignment research seems to me intuitively much easier than producing the alignment research. As is the case for like machine learning more broadly, I would say. So I am optimistic that we can probably produce a decent reward signal. Also, I have more like some areas I'm specifically looking into, which are related to the intersection of neuroscience and deep learning.
So
This
is a little bit like when people say, I cannot define this concept, but I know when I see it.
Yeah, exactly. Yeah.
So I don't know how to do the aligning agent, but I will know when it really works. I see.
Yeah, and it's related to all the theoretical arguments about, P versus NP. Verification usually tends to be
easier. Verification is always easier. Okay, so it related a little bit. So there is a school which is not very well known in alignment research because it comes from cognitive science, and it's very interesting for me that basically if you ask Yoshua Bengio, he says, don't put agency into AI, or don't put AI into agents. And by agents, he means something that acts in the real world, like a robot. And my intuition, which is aligned to this other school, is that we exactly have to do this. We have to put AI into agents because that's the only way that AI will align itself to reality. Like, we just have to trust that is like, okay, of course you will not put it in a bomb, nuclear bomb. You put it in a small robot maybe, or you put it in your toaster in your kitchen, and then it can confabulate as much as it wants, but it will have ways to check it. Like, in the scientific method, we generate hypotheses. If they are all true, then we're not doing our work. So there are false hypotheses, there are confabulations, but then we have a very embodied physical methodology to check whether what we think about the world is true or not. And this will only happen if it's in agents, and especially embodied agents that are physically present in the world.
Yeah, I think at least among AI safety people, they mostly use the term agency to refer to something closer to that idea of something like optimizing for a terminal state that I mentioned, or like consequentialism, which is kind of like that. So I think most within AI safety, that like agency is mostly used to refer to something like that, rather than something like embodiment.
I see. Okay,
Yeah.
so maybe this is just we don't use it in the same way.
Yeah, unlike agents versus oracles or something like that, like Yoshua Bengio's thoughts. Yeah, I'm unsure. As I was saying, I think there's a spectrum there depending on like how cautious you want to be. So like the more cautious you want to be, the more you want to go towards something like oracles. But then it might be harder to scale up automated alignment research if you need to have a lot of humans in the loop, for example. So yeah, I think that's something to, yeah, maybe that's just kind of like an empirical hyperparameter to figure out in some sense. Well, to figure out cautiously, I guess. On embodiment, I think I'm relatively optimistic that, and this is very related to like stuff I'm currently researching for, like trying to come up with an agenda. There have been a bunch of studies which look at language models and like language networks in the brains of people. And if you expose them to the same inputs, you can often correlate very well the insides of language models with fMRI measurements of human brains while they are exposed to the same inputs. And to me, that suggests that you have partially overlapping representations between language models, even if they are not embodied, and humans who are embodied. So I'm relatively optimistic that even language models have, for many concepts, especially abstract concepts, have quite grounded representations. And I've seen arguments also that maybe many of the most abstract concepts, like democracy, are actually grounded in language. Because, yeah, democracy, it seems hard, like what is the referent of the term democracy? Like, it kind of seems to me like very abstract concepts, almost by definition, don't really have or like it's harder to find a physical referent. And
That's not necessarily what I'm saying, that you need a physical referent. It's what I'm saying, that when you start thinking, so planning in my sense, in the reinforcement learning sense, you start generating futures like, singularity versus everything is good. There is no way to know which one is true, because it's about the future. It's a prediction. And so what we do is we confront it with reality. It can be, physical, like you bump into the wall is there. It can be social too. So it can be a hypothesis that you have about somebody. You talk, you confront, and it turns out to be false. And that's a way to check whether our confabulations are true or not. And the other thing is that, like, you cannot do this without, you cannot live without confabulating. So it's not a bug that language models confabulate. It's a feature. It's just they don't have now their only way to confront it with reality is reinforcement learning with human feedback. Like their confrontation now is that they get a thumbs down or thumbs up, which is already like a rudimentary test about what's true, what's not. But it's rudimentary, right? It will be aligned with that group of people who are doing the likes or dislikes, which is actually already there, like in recommendation engine, etc. So it's a technology that works for certain things. But if we really want AGI, like agents that are really intelligent, this is, for me at least, it's impossible without embodying them and letting them bind to the reality, bind to people in the sense of checking what's true, what's not true experimentally. Right? So this is what I'm saying. But then, it's a minority opinion, I know.
I think I mostly expect that people are gonna use language models in this way anyway. Like people are gonna try to make them like it's commercially useful for language models to know the truth in some sense, or to like, yeah, or
but
yeah.
it's more about not knowing the truth, but having methodologies to finding out the truth. And I'm not sure if a lot of people, I mean, maybe.
I also expect that, yeah, actually, in some sense, I wish this would happen slower, because, but I do expect people to try to overcome this problem in an automated way, in some sense. And I suspect quite a few people are probably thinking about something like this because it seems a commercially relevant problem. I would also say that it seems a bit scary in the sense of like pushing capabilities forward and potentially like shortening timelines to very, very capable AI.
Okay. So I want to talk about this because I think it's very typical and it's an interesting thing. So there's this metaphor that while I was driving back home to do this podcast, I was listening to an interview with Yoshua Bengio, who was one of the participants in the monk debate, and he was on the side of the cautious, or let's say the pessimistic side, with Max Tegmark, and on the other side there was Jan LeCun, which is very interesting because they're friends, and Melanie, and I think Max had this metaphor that basically we are in a river heading into a waterfall, and then the different people say different things about this, and Yoshua says we have to stop, and Max says it too, and on the other side it's more heterogeneous, so basically Jan LeCun says yes, we do, we'll figure out how to deal with this when we get there. And Melanie, I think there is a misunderstanding, because I think she's more sophisticated than what Yoshua says, because for me what Melanie said was we have a lot of rocks between this and the waterfall, and we have to deal with them first, so in a sense it's, yeah, let's deal with the waterfall when we get there, but most importantly deal with the stuff that will kill us before we get there. So where are you on this metaphor? Who would you be?
So yeah, I think I'm closer to Max and to Joshua than to Jan, and especially than to Melanie, I guess, which is probably not surprising since I work on AI safety. But I guess I'm like, compared to Joshua and Max, I'm relatively more pessimistic about first even like getting people to agree to pause now. And then also, like, one question I asked other people who seem more optimistic about pausing is, okay, even if we paused for like 6 months or 1 year now, what do we do with the pause? Because it seems to me, as I said, that before that, like, progress on aligning superintelligence is not going very well. Maybe we do get, maybe in that 1 year, we do get some progress on aligning large language models, and maybe we can use large language models to align superintelligence. So I'm not saying it's completely useless, but if like somebody said that like we can only get 1 year of pause and we can pick the time, but like that's it, I would not pick now. I would pick, as I said, something like automate alignment research. Then that's where I want the pause, because that's where you can produce a lot of alignment research in a short amount of time. So that's why, like, where I'm coming from. I think I disagree a bit. So like, I agree there are issues in the near term. I'm very happy there are people working on them. I would hope there would be more people working on them. So I agree with Melanie that like it's important to also handle the stuff in between. That said, I think it's very risky to be like, oh, we'll handle the waterfall when we're there, which seems, yeah, like Jan is also saying. I think that's pretty risky. That seems pretty risky to me. So like, ideally, I would want, as much pause as is feasible. I'm relatively pessimistic about getting it, and based on that, I would want us to get it when it can produce the most impact in terms of alignment research. Also, I have to say, I think many people in alignment are actually very optimistic about what AI can accomplish if we manage to align it and make it safe more broadly, and also solve the governance issues and so on. So, I was initially interested in this from like the very optimistic side, like recurrent all kinds of arguments, like AI can give you everything if you solve it. So I still have that optimism if things go well, but I feel like we have to work for that.
Absolutely, absolutely. But what's most interesting with this metaphor for me is that they all accept it. That there's this waterfall, and it's very, very, very telling how people think when they start talking about them within a metaphor. For me, it's not obvious that we are in a river, because the river basically, it's in a certain sense, it's so teleological to say that we are in a river. Like, that means that it's going, you know how the rivers are, it's like a tree but upside down. So there are a lot of ways to get in the river, but it all goes in the same direction, and you have the only thing you can do is to jump out. Whereas I think the world is not like that. It's a river upside down. So it's basically, it's branching like a tree. And so your choice is not jumping out or not, or stopping or not. You definitely have to deal with the rocks that will kill you now. So, and there is I don't see any, counter argument to what Melanie is saying. But in terms of the waterfall, it's not that we will deal with it when we get there. We never get there, because we will choose a branch where there's no waterfall. And on top of it, this is really related to what's your general disposition in life, how optimistic, how pessimistic you are, is that I trust that the world is not designed that way, Like, there is a certain way to live, to align myself. And if everybody does this and we do it as a society, we will choose a path where there's no waterfall. You see? And so it's really hard to argue with somebody who thinks that we are in a river and there's a waterfall and there's not much to just jump out. but it's not obvious to me that that's metaphor is how the world works. It's actually it's a metaphysical argument to say this, right?
Yeah, I hope you are right, and we are not on this path, which is kind of like dangerous by default if we don't do something. Um, I think I have more uncertainty, like much more uncertainty about that, based on a couple of things. So I think, like in the most abstract and general sense, like we don't have methods today to align powerful AI that we would be confident in. We don't even have methods like this for like existing systems, like large language models. We cannot even deal with adversarial examples very well, though this problem has been studied by a lot of people for like more than 10 years now. So like, I think purely technically, we are not there right now. I do hope that if I mean, there are a bunch of things here. Maybe we won't even be able to tell when we are very close, or like when systems are dangerous because they might be able to hide capabilities from us. So that's another potential worry. And even more, even if we are able to tell, like it takes a small number of actors who are less cautious and who might race ahead, even though maybe most people would agree that it's time to pause or to stop because things are getting very dangerous. So I agree that it's not guaranteed that like for sure we have a waterfall ahead. Like the problem might be there. Maybe the problem isn't like alignment might be very easy and solved by default. Maybe we're just that lucky. Yeah, maybe people just stop if they see the danger signs. But I would not want to rely on that, especially where we seem to be now technically, which doesn't look quite like that to me.
Yeah, no, I'm not saying that there are guarantees. It's very interesting. So for me, this comes from the this amazing success of the scientific revolution, that we are in a world metaphysically, which is everything emerges from the physical level up, and we accept only physical laws as hard constraints. And singularity, the paperclip maximizer, all these scenarios are not physically unfeasible. The reason why I think it will be really hard to implement them is because there are also top-down constraints of how the world works. Like from society down to humans, there are laws that seem much softer, like sociological, psychological laws that we don't accept as like hard laws, that make the world such that it's very unlikely that we will have a paperclip maximizing singularity. And this brings me to, Lex had an interview with George Hotz, the CEO of TinyCorp.
Mm-hmm.
It was amazing. If you haven't seen it, watch it. And he said something very interesting, is that he wants to open source AI. Like his goal is to, instead of stopping and controlling it, to give it to everybody, because he basically says that the best way to achieve the paperclip maximizing AI is to give it a small number of people who control it, because we will build the sort of tyrannical structures society as a society that will be able to manage that control. And those structures are exactly those ones where the general goodness of people will not emerge, because usually in those structures, who get on the top, let's say, more like to be sociopathic or psychopathic, bad people. And so to counter it, the best way not to get the paperclip maximizing singularity AI is to just give it to everybody, because if you give it to everybody, there are always much more good people than bad people. And we'll deal with, of course, it will be complex, it won't be controlled from top down, but somehow the world will just go on as it went on with other similar problems. So this is his argument. And I tend to agree with him. Like and basically it's a very important question, because do we open source or do we not open source? That's like a immediate question, and some companies like Meta does it, and they are fully signed up for this. Maybe not open sourcing all the weights of the networks, but at least the architecture and how we trained it, so we widen the people who can actually do the training, and you can make local AIs blossom.
Yeah, I think so. Like, I definitely agree that there are these governance kinds of problems of like who controls the AI, or like the AGI or the superintelligence, who gets to set its objectives. And so I do think those are very important problems. And I agree that there's definitely a risk that if you have that decentralized, things might go really badly. On the other hand, I don't fully agree with the idea of the like open source is obviously the way to go, because even if you suppose, and I think I would mostly buy the argument that like most people are gonna use it in a good way. I'm not so sure that like offense defense balance, basically, like just the fact that you have more good people than bad is enough to avoid really catastrophic outcomes. As a simple example, you can think of like an engineered pandemic, which seems to me intuitively like might require much fewer resources to like happen than to stop. And so there can be very like bad imbalances between like how many resources it takes to create a problem and then to solve it. And yeah, I feel like there are misuse cases like this one, which could go really badly. And so I wish I've seen arguments about open source. I think the vast majority of people in open source are probably well-intentioned. I am excited about tech in general. I just feel like in this case, fully going open source is probably not the best idea, at least if you don't like, I wish people would just think about like minimal measures, like at least when Facebook, to name call them, but yeah, puts out Llama, I wish they would at least think about, do we have like engineered pandemics capabilities in there, for example? And it seems like even GPT-4, I don't remember, but I think even RLHF GPT-4, like MIT students got some of those capabilities out of it with just 1 hour, in just 1 hour. And so I think, yeah, if we open source...
Yeah, I mean, George's argument to this, because Lex raised exactly the same argument, that the information is out there, and if somebody who wants to build a bomb goes to GPT-4 to build it, it's probably the dumbest idea.
I'm not sure. So like, I agree that maybe most of the most dangerous people already have a lot of that knowledge, but I also saw the argument, and I think I buy it, that GPT-4 lowers the threshold of like how much knowledge you need to potentially produce something dangerous. And I expect that will probably get worse with more capable systems. So like, yeah, at least if like,
no,
and I'm less optimistic about, in some sense, I'm less optimistic about, making models very robust to adversarial prompts than making them just helpful on average, because that seems kind of like the adversarial examples kind of problem, which people have not solved in vision for 10 years. So yeah, that just seems potentially harder than aligning language models on average.
So what is adversarial? What is this adversarial? Because you mentioned it several times, and maybe it would be a good idea to explain it.
Yeah, so adversarial examples are these images where these examples where people can just manipulate a single pixel in an image, for example. And so like the image looks indistinguishable to a human before and after the manipulation, but an AI can like say that it looks completely different. Like it might say that the first image contains a bus and the second contains an ostrich. And similarly for adversarial prompts, I mean, kind of similarly, is the idea that some users might prompt the system in ways which might be helpful to the user's intention, but might be detrimental to wider society. For example, like maybe the user wants to create an engineer pandemic, which maybe the system in that case is actually helpful to the user, but not like that's bad on a societal scale. And so processes like RLHF also try to induce like harmlessness into the system. Yeah, my intuition is that on average, GPT-4 seems pretty helpful to me. But like if you try to make it very robust to like never be harmful, that seems hard. That seems like a kind of like a strictly harder problem. So I'm relatively more pessimistic about solving that, like solving harmlessness very robustly than solving helpfulness on average.
Okay, but okay. I just don't see the link with the adversarial. So you mean like because of the adversarial examples, you're pessimistic about the harmfulness problem because there will always be like specifically designed prompts or ways. Okay, I got it.
Yeah, exactly. Yeah, like people are gonna optimize to make the system.
So we will have to live with it in a certain sense, no?
So I think unfortunately we might have to live with it for relatively weak systems. I'm more optimistic that maybe automated alignment research can solve this harder problem. So that's like my success story. It's like the harder problems, maybe you can get automated alignment research to solve.
Okay, got it.
Also potentially you might want to restrict capabilities. Like as I was saying, I would hope that the next llama or something that they try to delete those kinds of capabilities before, at least before making the weights public, or like having the weights leak publicly.
You mean the harmful capabilities?
Yes, like so. Yeah, maybe somewhere where we have decent reasons to want to take them out, like offensive cyber offense, like cyber weapons, or yeah, stuff which can help with engineer pandemics. I don't know, even stuff which like it's less existential, but like having them all help you make a bomb or something.
Okay. Well, Bogdan, it was really nice. I have one last question to you. Is what are your dreams? Where do you think this whole thing is heading? Where do you see yourself in 10 years?
Oof. So yeah, maybe one way to start this is to say that I'm worried that we might already have something like human level AI in the singularity in 10 years. So yeah, to be honest, I have like in recent times, I have not spent that much time thinking about what I would do in the very long run, especially because my timelines for the singularity basically have shortened quite a bit. And so, yeah, I expect that I will probably mostly try to keep working on this problem, or at least try to help bring in other people to work on this problem by doing field building. And yeah, if things go badly, I suppose I don't have to plan for it because I expect things will probably go very badly for everyone, unfortunately. If things go really well,
you have such fears for yourself?
I don't know if I would necessarily. So like, I think there's a mix of things there. So like, I think being cautious on a societal level is just reasonable. I think being fearful is not always helpful. For myself personally, I am probably sometimes more anxious than I wish I were, even if, to be honest, my like probability of doom is not that high. So I'm more in the 10% range than in the 90% range. But I still do think about it sometimes. Like, if we have just 10 years left, might as well, like work hard on this. Yeah, if things go really well, which I think is totally plausible and like quite likely actually. I haven't thought that much. Like probably just like start with a vacation, but it'll probably be a very long vacation because if things go well, I expect like amazing. Like I expect things to be amazingly good. Like the whole transhumanism singularity story. Like very much extended lifespans, a lot of like abundance, material abundance. Yeah, the whole. You
And then
probably know the story.
you would stop doing research on singularity if this happened?
What do you mean? Like after the singularity, would I stop?
No, if you have the positive scenario where everything is good and you
Mhm.
have everything you need for substance,
Yeah.
then you wouldn't do what you do today?
Um, well, like in one sense, for that to happen, I kind of feel like the alignment problem has to have been solved. So strictly working on alignment is kind of useless. But also more broadly, I would expect me to be much worse than the AIs at research anyway. So strictly from like, am I doing something useful? It would probably be completely useless to do research after that point. From a like intellectually
Ah, you
interested.
mean that AI will do all the research?
Yes, exactly.
Ah,
Yeah.
I get it. Okay. Okay, that's interesting.
Yeah.
And so what would you do then?
So
What would you do during your long vacation?
for a year at least, I would, I don't know, maybe travel. I haven't traveled that much. Maybe go to music festivals, maybe like catch up with friends, which also maybe I'm doing less than I might want to do. Yeah, and yeah, just plan ahead because I feel like probably life there will be a long life ahead if things go well. So I just like try to think about what do I actually want now that there is time to actually think about what I want in the long run, and there isn't any, yeah, potential danger very close.
It's pretty heavy
Yeah,
to
yeah, I know.
finish.
I know. Again, as I said, my like probability P doom, what AI safety people usually like, yeah, the yeah, probability of things going like us going extinct or like yeah things like probability of us going extinct. I'm more in the 10% range. So yeah, I
Maybe okay, in one time scale. Because we going extinct, everything
well
disappears,
yeah
everything is born and then
yeah in
disappears.
like I guess to simplify like on my like I expect AI on I don't know like my median is somewhere in the 5 to 10 year range. So like in the 5 to 10 year range, I expect somewhere around 10% probably that we go extinct because
I see that, but
basically
that's
we
pretty
don't solve
high.
alignment. Yeah, it's definitely like yeah, to go heavy. I expect that probably more than half of my probability of dying in the next 10 years is from that.
Yes.
So
Okay.
yeah. But that being said, probably 50% or more than 50%, I expect, or like a bit more, I expect things to go really well, like much better than like current life for like the vast majority of people, if not literally all people. So I think the upside is incredibly good. I think the downside could be absolutely horrible. But
Hmm. I understand. Now I understand you much better. So it was interesting. Well, thank you very much, Bogdan. It was a
thanks for the
great
invitation.
pleasure. We almost 2 hours in.
Thanks,
So
it was a lot of fun.
and yeah, and I mean, I'm optimistic. I don't fear to be dying of AI in the next 10 years, but I understand your arguments and you brought it closer to us. And
Thanks.
this debate, I think, a lot of this debate is about understanding where people come from, understand the emotions behind the fear, anxiety before the arguments, because sometimes the arguments hide that sort of personal aspect of this.
Yeah, on that, I think so. Like, yeah, I try to. So of course, I have my own like feelings and like, yeah, and they do affect like how I perceive the arguments and so on. But I do try to focus on like the arguments and less on like feelings. And yeah, I feel like we should probably try to judge based on the arguments mostly. Yeah.
Okay, well, thank you very much, Bogdan. This
Thanks for
was
the
fun.
invitation. Yeah, it was a
Yes,
lot of fun. Thanks.
yes. Thank you. Bye.
Thanks. Bye. you.